Today we're going to be talking about air masses. Air masses is the last sheet in your Earth Science Review packet. So, what are air masses? And why should we watch them? Here you can see an animation of an air mass. You can see air masses and movement of air masses over Australia. But what is an air mass? An air mass is a mass of air that forms over a certain region. The region in which it forms over determines that air mass's temperature and moisture content. We name air masses based off of their source region. What you should write in your notes is an air mass is an immense body of air that is characterized by similar temperature and amounts of moisture. The bottom area, the area over which the air mass gets its characteristics and properties, this has already been written into your note-taking packet for you. But let's talk about this. Let's talk about the source region. There can be four main types of air masses. Let's first look at maritime. Maritime is an air mass that actually forms over water. So like oceans. And because a maritime air mass is forming over oceans, it has a lot of moisture. So when we think of maritime air masses, we think of them as being wet. Notice that when we indicate a maritime air mass, we use a lowercase m. Please, on your note-taking packet, please write in maritime air mass forms over water and is wet, and then also draw a small picture, like a rain cloud. Let's look at our next air mass, continental. A continental air mass is one that forms over land. Think of continents, and our continents are land masses. So when air masses form over land, they are very dry. In your note-taking packet, not only define continental, but also draw a picture. Notice that we indicate a continental air mass with a lowercase c. So if an air mass forms over water, or land, we indicate it with a lowercase m or a lowercase c. When we talk about the temperature of an air mass, there's two words we can use. One of them is polar. And a polar air mass is an air mass that forms over a region that is cold. So like the North Pole or the South Pole. When we talk about a polar air mass, notice that we indicate it with a capital P. In your note-taking packet, please define polar and draw a picture of something like a snowflake. The second temperature air mass we can have would be a tropical air mass. And a tropical air mass, you guessed it, it develops in the tropics. So it develops in a warm area. So when we talk about tropical air masses, we're talking about warm air masses. Now let's look at this in more detail. Let's look at a map of the United States. Do you see how it shows you the different air masses? Do you see how we can see the abbreviations like M for maritime? Do you notice how it is formed over the ocean? MP for polar. Do you notice how it is formed up north in a cold polar region? So how would you describe this air mass right here? Yes, the air mass would be wet and cold. Let's look at this air mass. This air mass is forming over a majority of land. So it would be continental. Again, it is forming up north. So it would be polar. So if we were to describe this air mass, we would say that this air mass is dry and cold. Let's look down here. If an air mass forms over the region of Texas or Mexico, the air mass would be tropical because it is warm in this area, but it would also be dry because it is forming over land. If you look at these two air masses, you can see that they are forming over the oceans, but along our equator, which is a warm region. So these two air masses would be called maritime tropical, and they would be warm and wet. Let's take this information and actually fill out this chart that you have in your note-taking packet. So let's first draw our eye to the top two boxes. On the top two boxes, you can see that it says wet and dry. And then you can see on the side we have warm and cool. So what we're going to do is we are going to identify what would the air mass be called if it was warm and wet. Let's first talk about this whole maritime and continental. We know that if it forms over water, it would be wet and it would be maritime. So what you would write here is you would write a lowercase m for maritime. Now notice that not only is this air mass forming over a wet region, but it is also warm. So this would mean that it would be tropical. So you should have written maritime tropical. Let's look at this next one. This air mass is forming over a dry region. What word do we use when an air mass is forming over dry land? Think of our continents because it is a continental air mass. And it too is forming over a warm area, like around our tropics. So this air mass would be considered continental tropical. What I would like you to do now is I would like you to do the bottom part of this sheet on your own. So I would like you to take a moment and define the bottom two air masses. So I want you to tell me if they are going to be continental or maritime, and I want you to tell me if they're going to be tropical or polar. I'll be checking this tomorrow. When you are done, go ahead and flip your note-taking sheet over. Because when we talk about an air mass having a lot of moisture or very little moisture, there's a whole nother word we attach to that. And that word is humidity. So let's define humidity in our note-taking packet. What is humidity? Humidity is looking at the amount of water vapor that is in the air. So weathermen, you oftentimes hear them in the summer saying that we have 100% humidity or 80% humidity. That means that when we're looking at the amount of moisture that the air can hold and the amount of moisture in it, that it has about 80% of its maximum amount of water vapor contained within the air. Nebraska is known for being a very humid state in the summer. Our air is very warm and it has the capacity to hold a lot of water moisture, and it tends to do so. Let's look at another word that's associated with air masses, and that's air pressure. Air pressure is the force exerted on the surface by the air. High pressure systems, when we talk about them coming, they bring cooler temperatures and clearer skies. When the weatherman talks about a low pressure system coming in, he is talking about warmer weather coming with storms or possibly rain. It's the combination of all of these things together, air masses, humidity, and air pressure, that actually create things like our weather. So let's look at how weather forms. Weather happens in the formation of fronts. Please define front on your note-taking sheet. Notice that a front is really where two different types of air masses meet. So you could have like a cooler air mass meeting a warm air mass. Now, whatever air mass is the one coming in, the direction in which the air mass is moving, that's what names the actual front itself. So let's look at this in a little bit more detail. Here you can see that the direction of the front is this way. It's moving to the right. So what's moving in? The cold air. So this is called a cold front. When we have a cold front, we oftentimes have very heavy rain, and in worst case scenarios, we can have things like tornadoes. Now let's look at this one. Notice the direction of the front. What's coming in? Well, it's the warm air. This would be called a warm front. We can have two other types of fronts, and those fronts are called stationary and occluded. So let's look at this really quick. An occluded front, notice you actually have three different fronts that are coming together. We have cold air, even cooler air, and then warm air. Notice that as the two cooler air masses meet, the warm air is then pushed up. A stationary front, well, you guessed it. You know what the word stationary means. It means you're not moving. And when we have a stationary front, it's when a cold air and a warm air mass meet, and neither of them are budging. No air mass is moving above or below. They end up being stationary. So, let's talk about how these air masses are moving in the first place. How do air masses move? air masses are affected and moved by wind and jet streams. Wind occurs because you have air that is trying to move from an area of high pressure to an area of lower pressure. Let's look at this in a little bit more detail with images of things that you might see in your daily life. Did you notice when I was showing you images of a cold front or a warm front? Did you notice that the warm air always went up and the cold air always was underneath? This deals with density. Do you remember density when we talked about physical properties of matter? Remember that the most dense objects will always sink and the least dense objects will always rise? Well, guess what? Air masses have density too. So cold air is more dense, so it will always sink. And this is why we always find cold air masses below. And warm air masses, well, they're less dense, so they will always rise. So when you ever have two fronts meeting each other, the cold air will always slip underneath, while the warm air will rise up above. The two air masses will not mix. It's kind of like oil and water. It doesn't matter how much you try to mix the oil and water together, the oil will rise to the top and the water will be below. Let's talk about one other thing. When I told you that air masses move, I told you that they move due to high pressure systems and low pressure systems, and then that creates wind. But I also said there's something called jet streams. What are jet streams? This is the last term you'll find on your note-taking packet. Jet streams are bands of high-speed winds that are about 6 miles above the Earth's surface. When we look at jet streams, you probably are aware of these. If you've ever been in an airplane and maybe the way out to Michigan versus the way home from Michigan took more or less time, this would be because you're either taking advantage of the jet stream, and so the airplane is actually riding the jet stream, allowing you to get to your destination quicker, or you're going in the opposite direction of the jet stream and it's actually slowing you down. So when you think about jet streams, think of them as these high-speed winds that are occurring above the Earth's surface. Like I said, jet streams help meteorologists to predict the weather, and it also helps pilots figure out the fastest and quickest way they can get to their destinations. Tomorrow, we will be reviewing the different types of air masses we can have and how we describe them: maritime, polar, continental, and tropical. And we'll also talk more about when air masses meet and we have things called fronts. Be ready to do a lab.